All right, we're going to continue our look at applications for percentages. And we're specifically going to look at where percentages come up a lot in life, which is sales tax, commissions, and discounts. There are common places where we talk about percentages. Sales tax is a common one. So, what we have is the sales tax is whatever the tax rate is times the purchase price. The total price is the purchase price plus the sales tax. And a neat thing happens here. I want to use some variables. The sales tax, I'll call T, is the tax rate times the purchase price. The total price, so I'll make this a capital T, is the purchase price plus the tax rate. Now, a neat trick comes out of this. If I replace this into T, I get this. And our law of distribution says, well, I have something times P plus something else times P. So I can pull P out to the front. And I get 1 plus the rate. Well, if our rates are all decimals, like if I have a 10% sales tax, we'll say if the tax rate is 10%, we write that as 0.10. And so if I add 1 to that, my total is 1 plus the rate times P. And that usually means 1 plus R, I drop a 1 in front of the decimal. And this is usually the easiest way to calculate the total price. We'll build it up by pieces, and then we'll look at this way also in it. So let's look at an example here. And we'll do it both ways. So a bracelet sells for $1,800 with a tax of 6.5%. So the sales tax, which I'll still call lowercase t, is equal to the rate. So my rate is this percentage. I want to convert that to a decimal, so I'm going to move the decimal place over twice. So this would be 0.065 times the price, and my price is $1,800. So the tax, I run to the calculator, and I get $117 of tax. The total price is the purchase price plus the tax, or $1,800 times, or not times, plus 117, which is $1,917. So the total price of this bracelet is $1,917. Well, if we do the other version, we say the total price is 1 plus the rate times the original price. And so that would be 1.065 times 1,800. And I put that into the calculator. I get $1,917 also. So both of these methods are useful in calculating the total price. I would, as you get used to it, use this method. Once you're comfortable with that, start looking at this method. This is a great way to quickly do it. It becomes one thing you enter into your calculator. Get another one. An automobile sells for $18,500. So that's my price of automobile. And the sales tax on that, the sales tax comes out to be $1,665. So we want to find what was the tax rate. And I know the rate times the price equals the tax. So my rate, I don't know. And I'll divide both sides by P. So I get T over P. And that means the rate is $1,065 divided by 18,500. Now notice this. This was like a percent, this was like an amount, and this was like a base. So this would be the same as P equals A over B from our previous proportions. We're just using different words because these are how these words come up in the things we do. And I run this into my calculator, and I get a 0.09 for my rate. Change that to a percent. I'll move my decimal twice to the right, and that's 9%. And so the sales tax rate is 9%. All right, another thing that happens is you can get a commission. Commission is when you get a percentage of your sales as a bonus or a salary incentive. And so the commission is your commission rate times the value of the sales. Notice how rates are popping up in here. And so rates become the things we use. So let's say a sales representative sells, so sales rep sells $47,632 worth of office supplies. In a month. Their commission rate is 6.6%. So what is their commission? So we'll say the commission is equal to the rate, which the rate is 6.6%. We'll change this to a decimal by moving the decimal place over twice. That's 0.066. And their sales were 47,632. So this is a nice entry for my calculator. And I get 3,143.712. But I can't get a fraction of a penny. So they will get a $3,143.71 commission. So the commission double S's in commission. Commission on their monthly sales was $3,143.71. Another way this pops up is discount prices. So you have the amount of discount and the sales price. And so the amount of discount, so the amount of the discount is equal to the discount rate times the original price. The total sale, the sale cost, so A is amount of discount R is the discount rate, and P is the original price. S is the sale price, and so the sale price is the original price plus the amount of discount, or minus the amount of discount, I should say, minus. So minus the discount. Again, if we do the substitution, we get P minus RP. I can pull out the P, and I get a 1 minus the rate this time. That means if I have a 25% discount, 1 minus that, so 1 minus 0.25 turns that to 0.75. And there's kind of pairs that you can look at for certain discount values. And so we can calculate this two different ways. We're going to focus on this way, figuring out what the amount of the discount was and subtracting it. But know that if you know these pairs, you can use this as your multiplier. So let's say a dress is marked for $2,000, but there is a 30% discount. So the amount of the discount, well, our sales rate is 30%. I'll convert that to a decimal by moving the decimal place over twice, so it's 0.3. So the rate times the original price. And so my discount, running to my calculator, is $600. So the cost of the sale, or how much I have to pay at the register, is the original price minus the discount, or $1,400. So the sale price of the dress is $1,400. If we look at it the other way, if I look at the rate, and 1 minus 0.3 is 0.7, so I can say the sale price is 0.7 times the original price, and I run to my calculator. I'm going to get $1,400 also. So both of these methods work in applying a discount and getting the total cost. And these are some common applications of percentages. We'll look at one more set of applications as we wrap up this module.